Hello guys, good morning. All set guys? How are you guys? What's going on? How's your morning? Shillong? What about other centers? Quickly tell me. How many centers are present other than Shillong? Hi Senapati, morning. So guys, we were discussing about we were discussing few questions in the last class. Hi Itanaga. Ready guys? Can we start? Guys, first of all tell me how many students are present and how many absent actually. Every center. Give me a quick count of present and absent students. Shillong, Itanagar, Senapati, every center. Eight are present. How many absent? Thirteen in this class. Okay, what about other centers? Okay, all present. How many students? Senapati? 2 sections. So 13's. Okay, Shillong, tell me one thing. But I think chemistry would be combined. So 1 section is present right now, Shillong. Okay, fine. So guys, let's start. In the last class, we have discussed few questions, and today we'll continue with both the sections are present, but number of absent students are very high actually. And is there any reason that why the number of students are absent? Shillong? 8 in the other class. Okay. I'll talk to you. Fine. Okay guys, let's continue with the further concepts in the organic chemistry. I think we have discussed few of the mechanisms and we have to continue with that. So now, today, we will start one more mechanism, which is the Perkins reaction. Perkins reaction. Guys, again, Perkins reaction is very much important for your examinations, for your entrance examination, NEET point of view. Obviously, you should remember the product, that how product is, what is the product, and you should also know how this product will be formed. See, this is a kind of specific reaction. In this is your benzaldehyde, PHCHO, is treated with anhydride, CH3, C double bond O, CH3, C double bond O. See, now, when you treated it in the presence of a base, let's suppose this is the base, CH3. Guys, nobody will note it down right now. You have to understand that how mechanism will proceed. You have to first understand the mechanism, and then I'll give you some time to note it down. ONA in the presence of CH3COH. This is the first reagent that you have to use. And the second time, in the presence of acidified water, you will heat and you will get the product. So guys, this is the Perkins reaction's main motive. Now, how this reaction will proceed? Remember one thing, the mechanism that we have discussed in the last class, this will also proceed in the same manner, because this is also the enolate mechanism. Enolate means that we were discussing in the last class, for example, like Kenny-Zaro reaction, or you have studied about the aldol reactions. Okay, this is exactly same kind of mechanism. Now look at this, how this one will proceed. See, this is your first step. Now we have got a base CH3 CO minus, and we know that this one has the alpha hydrogen, this is the alpha carbon. Now look at this. What will happen? This will attack to this hydrogen. This will attack to this hydrogen and this bond will shift over there, and you will get this one, CH3 COH plus CH2 CO O COCH3. This is step number 1. Is there any doubt in the step number 1? This is simply the acid-base reaction in which, or not the acid-base reaction, but it is simply a reaction in which base attacks to the alpha hydrogen. Any doubt in the first step, guys? Okay, cool. Note it down quickly. The step number 1. I mean, till now that I have written for you. Note it down. Done, guys? Done? Okay. So let's move on to step number 2. Now, in the step number 2, look at this very carefully. This is our benzaldehyde, and this is the anion that we have got by the previous step. See, we know that this is the electrophilic center. Obviously, it will be delta positive and this one will be delta negative. So now, what happened? This one will attack to this carbon and this bond will shift over there. And after this step, it will look like this. See, pH CO minus H CH2 O COCH3. This is our step number 2. Now, in the step number 3, I'll continue with this step. Acid will come over here and provide the proton to this negative charge. This is the acetic acid that we have got in the first step. pH COH H CH2 CO O COCH3. So guys, this is step number 2. I hope so. Everybody has cleared this step number 2. Any doubt for the step number 2? Guys, note it down. Step number 2. And quickly tell me that you have noted it. Guys, is there any doubt regarding first 2 steps? Any doubt regarding first 2 steps? Okay, I'll show you for you. Once again. Guys, first of all, note it down step number 2. Shillong, have you noted it? Okay. Step number 1 for Itanagar. Note it down quickly. Done, Itanagar? Okay. Okay guys, let's move on to step number 3. See, we have reached up to this step pH, CHOH, CH2, C double bond O, O, COCH3. Now, when I treat it with acidified water, see, this is actually your leaving group. This behaves as a leaving group. Okay. What would happen over there? That this group, we can say, let's suppose this one, this group will release from here and you will get this one. This one. Simply in this step, this bond will shift over here and you will get a negative charge and H plus will be attached to that, and after that you will get this acid. Now in the last step, when you heat it, removal of water will take place. This is your alpha carbon, this is your beta carbon, and H and OH will be released from here. See, in this manner, this is your H and this one will be released from here and you will get PH, CH, double bond, CH, COH. And this compound is known as the cinnamic acid. Guys, note it down. Now again, look at these three steps and quickly tell me, is there anybody has got any doubt regarding this mechanism? Anybody has got any doubt? Guys, tell me, is there anybody has got any doubt regarding in these three steps? Senapati, Shillong, I'm not getting any response from the Shillong. Shillong, what's going on, guys? Do you have any doubt in these steps? Anybody? Shillong? Okay, cool. Okay. So guys, ultimately you have to remember the final product for this particular reaction, but you should also know the mechanism, that how does it proceed. Okay. Now, after completion of this, we will discuss about the nitrines. In the nitrines, we will deal with the some important mechanism that belongs to the amines chapter. Okay. Guys, remember one thing, that I'll discuss the first of all general idea that how reactions proceed with nitrines. And remember one thing, I'll club all the reactions so that you can memorize them very easily. Ultimately, in every reaction, there will be there will be one or two steps at max that would be quite different. Otherwise, the mechanism will proceed in the same manner in the every reaction. So you have to understand the basic funda, that how this reaction proceeds, and after that it will be very easy to learn these mechanisms. Okay. So is everybody ready for the nitrines? Okay. So guys, let's start. Some important mechanism of amines. And our topic is nitrines. Guys, first of all, understand what is this nitrine stand for. It is represented like this. Lone pairs. This small box represents the vacant orbital, and this is the bond. Okay. So this is the simple representation of the nitrine. So now we will deal with all those mechanisms in which this nitrine is involved. First of all, let us understand Some basic properties of this nitrene. See, nearby, how many electrons are there? See, 1, 2, 3, 4, 5. There are 5 electrons. So we can say there are nearby 5 electrons. Next, it is a neutral intermediate of nitrogen, we can say. So it is the electron deficient neutral nitrogen intermediate. Next, if I talk about the, sir, what is this square small thing? I have told you, dear, this is the vacant orbital. This represents the vacant orbital. Next, if I talk about the shared electrons, so you can see 5 are the electrons that nitrogen has, and there is one more electron, which is this one, which is shared with the nitrogen. So we can say there are 6 shared electrons. Next, it is neutral. Neutral we have already written over there. We can say incomplete octet. Next property is incomplete octet. Note it down. Note it down, guys. Done? Guys, kindly respond quickly so that we can proceed. And guys, remember one thing. Okay, that's cool. Guys, remember one thing. When I am writing something for you, please do not copy it with me. You have to wait for some time. Remember, guys, you have to understand the funda, concept. Okay? Because all these things are written in many books. Okay? So our motive is not to write these things in your notebook. Our motive is to understand the concept, what is actually going on. Okay? So first of all, make it clear when I am writing something or I am trying to make something understand to you. So you have to learn that first of all. And after the learning, I will give you some time to note that particular thing. Okay? So everybody will make sure that while discussing the concept, nobody will try to copy it. Everybody has to focus on the concept and make sure that each and every term, a word which is I am writing for you should be clear to you. If we are doing that, it means we are doing good. But if in the 2-hour class or 1-hour class or 1.5 hour or 3 hours class, I am writing something for you, you have copied it and then over. And you would understand nothing, then guys, this is not the right way to learn the things. Okay, then we are doing absolutely wrong. Okay, so guys, make sure that first of all you have to clear the concepts, because in the examination you have to deal with the questions. If your concepts are clear, you would be able to solve the questions. That's what we are trying to do over here. Does it make sense, guys? So make sure that nobody will copy at the same time when I am writing for you. Okay, you have to understand that time. Okay, I hope so everybody has done this. Now First of all, let us discuss how these nitrates are formed. Okay. See, I'll teach you a concept, then I'll give you a few questions. If after learning that concept, you are able to solve those questions, it means we are doing really good. Okay. If you are not able to solve even a single question, it means there is absolutely something wrong. Okay. So first of all, identify that are we doing good or not. Okay. For that you have to make the concepts clear. Now just focus what I'm telling, what I'm saying, what I'm trying to convey you. Okay. You have to grab it. Now we will deal with the formation of nitrates. This is the formation of nitrates. See, this is the first method. Look at this. I'm taking a general reaction. This is the R. R can be your any group. Any group. We don't know about the group. It can be anything. Now, it is connected with N, double bond N, double bond N. There are a lone pair. There are two lone pairs on this nitrogen, and here it has the positive charge. Can anybody tell me what is the name of this particular sequence, N double bond N double bond N? There are three nitrogens consecutively written over there. Is there anybody who knows the name of this particular substance? Anybody? What is this N3? N double bond N double bond N. Okay. Guys, I hope so you have heard a word about the azide. This is actually azide. This N3 is known as the azide. So now, what happens over here? See, this electron pair would shift over here, and this electron pair would shift over here. And after the shifting, it will look like this. R, N, electron pair, there will be single bond because its electron pair is shifted to the next nitrogen. It will still contain the positive charge because it has taken one electron but given one as well. So no net charge in there is no change in the net charge. Here you will get this one. And if you look at this compound clearly, you will find out that this is actually N2. This is actually N2, which is a very good leaving group. Okay. So what would happen in the next step? If you heat this compound, there will be negative charge as well. If you heat this compound, nitrogen is a gas, it will escape out very easily. So we can say this bond will shift over here, and you will get R, N, N, lone pair with this vacant orbital, plus you will get N2. Guys, tell me, are you clear with the step number one, or sorry, method number one of formation of the nitrates? Any doubt regarding any step in the formation of nitrates? Guys, note it down. You can note it down. Have you noted it? Shillong, raise your hands once. Okay, that's nice. The doctor at the first bench. Yeah, that's nice. Okay. Shillong, is there any doubt regarding the formation of formation of nitrine, the method number 1? Any doubt? See, after learning these few things, you will find out that all those mechanisms which are related to this would be very, very easy to you. But only the one thing that you should clear with it. Okay guys, I'll give you a few questions and you have to answer those questions. Okay, at last guys, this is the main funda, that how we deal with the mechanism. Ultimately you have to remember one thing. I hope so everybody is noted down. Ultimately you have to remember one thing. Whenever this pattern comes, and you heat the compound, you have to do only one thing. Remove this N2 and just write this one. That's it. This is ultimately way to write the answer. That you have to write the answer. You have to think about it. That's it. That how can you write the answer. Okay. So I'll give you a few questions. Remember, you have to write the answers only, nothing else. Okay. Do these questions. You can note these questions with me and you have to answer them. Guys, do these questions. Four questions, 1 minute, just to write the answer. Attempt these questions, then we'll discuss about it. Done? Okay. So let's discuss these questions. See, for the question number 1, your answer should be this one. You have to check and tell me how many right answers you have got. And for the last one, again you will get the same answer, because this is the carbon monoxide, a gas. Okay, this is the carbon monoxide. Any doubt? Any query for these steps, for these questions? Any doubt? Anybody? Okay. For this one, remember the electron pairs which are present over there will be shift over here, and this one will be shift over here, and after that removal of this CO will takes place. This is the one method for the formation of nitrene. Now let us discuss about the second method. Say you have got pattern like this. This is the L. You can use a base. Let's suppose OH minus, or we can say CH3O minus. Okay, any strong base. You will get R N with vacant orbital. BH will be released from here with leaving group. Okay, this is the way to write the answer. That how to write the answer will deal with how this reaction would proceed. Okay. See, if I talk about the mechanism, this is R, this is N, H, and this is L. Guys, remember L is a leaving group. This is your leaving group. Okay, this is L. So when you use a base, it will definitely attack to the center where it can get a proton, and we know that there is only a one proton over there, so it will be released from here. This bond will shift over there, and after that the leaving group will be released from here, and you will finally get this pattern. BH plus leaving group. Any doubt regarding this mechanism? Anybody has got any doubt? Anybody want some more clarification on this one, or is it clear to you? Itanagar, Shillong, Senapati. Any doubt? Any problem? One more thing, guys. In most of the cases, you can remember that the L will be chlorine, bromine, iodine in most of the cases. Guys, have you noted it? Why not F? Because F, the bond between F and N would be quite stronger. Ultimately, first of all, it is very difficult to form, and second thing, if it is formed, then it is very difficult to break. Okay? Or ultimately, we may say that the weak bases are the good leaving group. Remember, fluorine is not a weak base. Fluorine is a very strong base. Okay? If ultimately you get a fluorine as a leaving group, it will donate again its electron pair uh, to make bond with the proton. So what will happen? This base will not participate in the reaction. Ultimately, fluorine will replace it. That's why we are not using the fluorine. We need a base which is weaker than this one, this particular. Any doubt, Shillong? Guys, one thing. Is it clear to you? First of all, Shillong, tell me, is it clear to you? Who asked me this question? Okay, that's cool. Guys, first of all, remember one thing. Sometimes it happens that you ask me a question, and I give a quick reply on it. And it happens sometimes that it doesn't clear to you. It might happen sometime. Okay. So guys, remember one thing. I have many ways to explain a certain thing. That might possible that the first way I'm dealing with you is might not much clear to you, or remember many a times it will be clear to you, but I'm talking about the sometime. That time which at that time it is not clear to you. Guys, remember you have to ask it again until unless it is not clear to you. Remember, you have to make each and everything clear. If you are able to do that, it means everything is okay, everything is cool. Okay, that's fine. Okay, once Shillong, raise your hand. Is it clear to you, Shillong? Shillong, yes, very good. So guys, let's move on to few questions. I hope so. Everyone has cleared with these two methods, that how can we form the nitrine. I'm giving you a few questions and you have to answer those questions. Okay, there are questions for you. First, guys, think about the questions and write the answer. Guys, write the answers. Tell me the answers. Think about the questions. Ultimately, you have to target that substance that we were just discussing. Your focus should be on NH and Cl, that's it. The other attached group can be anything. It can be anything. Done? Shillong, Itanagar, Senapati, have you done it? Okay, that's cool. So let's see what would be the answers for these questions. This is answer number 1. I'm not writing the byproducts. Because in organic chemistry there is not so much importance of the byproducts. Okay, who has got all 4 right answers? Shilong, you can raise your hand. Who has got all 4 right answers? Everybody has got the right answer. Okay, that's cool. Okay, that's fine. So guys, there are 2 ways by which we can got that nitrine, and after the getting nitrine, we will have to deal its reaction, that how will it proceed. So before that, we have to discuss one more important thing, which is Wolff rearrangement. Wolff rearrangement. Guys, focus on it. Wolff rearrangement. See, we have got this pattern, and this is our R group. That can be anything. These are the electron pairs. Okay. Now, what happened actually? There is attraction between this electron pair and this vacant orbital. Okay. So what happened after some time? These electron pairs make bond with the nitrogen, and it rearranges into a new substance that look like this. That look like this. R. Remember, this bond will shift over here. Now R is connected to N. N is connected to C, and C is connected to. Kohima center is also there. Hi Kohima. Guys, first of all tell me, have you got this concept? Tell me first of all that have you got, oh just 1 second. This is not visible to you, I guess. 1 second, 1 second. This is R. At Kohima, dear, why are you standing over there? You can settle down, sit down. I was talking to Kohima Shillong. It's okay. Now tell me first of all, have you understand the Wolff rearrangement? Because this is the core concept. Ultimately, this is be used in every reaction that I'll deal with you. Tell me, is it clear to you? Okay, guys, now we have to use it. Look at this. This is the next important step, that how it will convert into acid. See, this is R, this is N, double bond C, double bond O. For example, we have got OH minus. We know that this is the electrophilic center. So OH minus will attack to this carbon and this bond will shift over here. You will get R, N, negative, C, double bond O, and then OH. Okay. What happened over here? Look at this H very clearly. Be careful regarding this H, because this H will be transferred over there. So there will be proton transfer, H plus transfer. And it will look like this. R, N, H, C, O, O minus. And after that, we know that there is water as well. So you will get R, NH, COH. Okay, just a second. See, R, N, H, COH. Guys, any doubt regarding this one? Because ultimately these first of all, the formation of nitrine, second, the Wolff rearrangement, and the third, how base attack on that. This is the core section of the mechanism that we are going to discuss after that. If you understand this, you will be very easily understand, or you will be able to understand the mechanism very easily if you are clear with this one. First of all, tell me, is there any doubt till now that I have discussed with you guys? Anybody, any doubt? Quick reply on the chat screen. Quick reply. Every center has to reply. Itanagar, Shillong, Kohima, Senapati, everybody. Guys, any doubt? Anything? Done? Okay. So guys, let's move on. So finally, reaction that we'll discuss with these, reaction to be discussed. First, Hoffman bromamide reaction. Next, Lawson reaction. Guys, you can note this with me because this is just the list of the reactions.
courteous reaction, then skimmed reaction, and last is your Beckmann rearrangement. Note it down, guys. Done? Sir, is this amine chapter? I'll make a list in the amine chapter. No, I'll start amine chapter. These are important reaction of the amines actually. But remember guys, when I'll teach amines, these reactions will be used over there, and I'll make a list of these reactions only. I won't teach you again these reactions. Remember. This is a part of the amines reaction actually. Remember, we are dealing with the nitrogen compounds, organic compounds containing nitrogen. So rather than discussing these reactions at different places, I have clubbed all these reactions at the same time because they all follow the same path, and it would be very easy to remember these reactions after discussing this. Have you done this, guys? Have you noted it? Shillong, Itanagar, Kohima, Senapati. Okay guys, so let's start. First is Hoffman reaction. Okay, this is the general reaction for this one. This is amide. We are using Br2 with KOH. You will get RNH2. Okay. One thing that you have to remember, that you might use Cl2 with KOH, or it can also be written like that, KOBr or NaOBr, or KOCl or NaOCl. Guys, first of all, note this. Remember Br2 KOH or Cl2O KOH, and remember Br2 and KOH can be written as KOBr, and also it can be written like that NaOBr if you use NaOH in spite of KOH. Okay, or you can write it like this, KOCl or NaOCl. Ultimately this is the halogen where you have to focus this. Okay guys, so this is the product. We get 1 degree amine from this. This is 1 degree amine. Now let's start with the mechanism. Quite important. See, guys, everybody has to clear each and every step. R CO NH2. I can write NH2 like this. There are lone pairs. Now, in the first step, base will come and it will abstract the proton, and after that obviously you will get a negative charge on this one, and it will look like R CO N with a negative sign H, and H2O has been released. Now this is step number 1. In the step number 2, R CO N H will attack on Br2. See what happened? When this attack on this Br, this will be released from here and it will look like this. R CO N Br H and 1 Br with negative sign. So these are the first 2 steps. Is there anyone who has got any doubt regarding first 2 steps? Guys, anybody has got any doubt regarding the first 2 steps? Tell me. Any doubt regarding first 2 steps? You can note down these 2 steps. Okay, note down these 2 steps. Then we will use the third one. Have you noted it, guys? Have you done this? Okay. So guys, there are the first 2 steps. Now let us discuss about the next one. Step number 3. In the previous step, we have got R CO N Br and H. Guys, look at this very clearly. This is the step by which we got the nitrines. This is the leaving group Br. See, this is Br leaving group, and this is the H. Okay, and we are using the base. So after this reaction, you will get R, CO, N, vacant orbital, and these electron pairs. Any doubt regarding the step number 3? As we come up with the step number 3, you can easily observe that this will participate in the Wolf rearrangement. See, this electron pair will shift over there. This R will attack to this nitrogen to make bond with this. See, this is the part of Wolf rearrangement. Now you will get R, N, double bond, C, double bond, O. And after that, C, R, N, double bond, C, double bond, O. If I use a base, obviously this is the electrophilic center. This is gonna be attack over there, and this electron pair will shift over there, and it will look like this: N, C, O, OH. One thing, O, and then H. Now this H will be transferred, which is known as the hydrogen transfer, or not hydrogen, proton transfer. Okay, and after this transfer, it will look like this. O minus. Now guys, look at this very carefully. Observe that if I shift this bond over there, there is actually a CO2 gas, and which is a good leaving group. So in this step, CO2 will be released. This bond will shift over there. We will get R, N, negative charge, R, N, negative charge, with H. Again, where to write? Okay, there is no space, guys. First of all, tell me, is there any doubt regarding first 5 steps? Or just 1 second. Just 1 second. I can write it here. 1 second. R, N, negative charge. This is H. And CO2 is released from there. Now, if we use water, again I'll get one more hydrogen, C. This is H, and I'll get one more H from there. So finally I have got this RNH2. I think that is not visible over there. Okay guys, note it down. I'll write it for you again. You can note it down up to this step, or yeah, first of all note it down up to this step. Guys, tell me, is there any doubt regarding the first 5 steps? Any doubt regarding the first 5 steps? I think we are using the previous concepts, nothing new. Note down. Guys, have you noted it? Shillong, Itanagar, Senapati. Have you noted it? Note it down quickly, guys. Shillong, what's your status? Okay, so guys, let's move on to the last step. We were at R, N, H. Lone pair with negative charge. In the last step, we are using H2O. We will get R, N, H, and this H. Guys, first of all, make it clear that I am writing H with different colors. It has some meaning. You have to remember that these hydrogens, this one and this one, are coming from the solvent. These are not those hydrogens which are actually present in the beginning of the reactions. These hydrogens we are getting from the solvent molecules, which has a importance actually during the questions. You have to remember these hydrogen atoms are coming from the solvent. So guys, that is all about the Hofmann bromide degradation reaction mechanism. Is it clear to everyone? Anybody want to ask anything in the first 6 steps? Any doubt? Any problem? Do I need to repeat it? Or we can directly proceed to the questions? Anyone? Okay, that's cool. So guys, I'm giving you a few questions. You have to solve those questions based on the Hoffman bromide degradation reaction. Okay? Questions. You have to write the answers only, guys. Guys, write down these 4 questions first. These 4 questions first. Answer these questions, guys. Then proceed. Answer these questions. Itanagar, what's your status, Senapati? Okay, that's cool. So let's write the answer. So this is the question number 1, and the answer would be CH3, CH2, NH2. In the next one, H, PH, CH3, NH2. One second, guys. Hey guys, back again. Due to some error, those questions have been disappeared. So I'll write those questions again for you. I hope so everybody has noted down those questions. See, this was the question number 2. pH, H, CH3, CONH2. We were using Br2 and KOH. This is the question number 2. So the answer for this question would be pH, H, CH3, NH2. Now, question number 3. In the question number 3, I guess this was pH, CO, and D2 with Br2 and KOH. So answer would be pH and H2. Okay. Last question was like this: pH, H is a dash bond, CH3, CO, and D2 NaOBr, and your answer would be this one. Guys, is there any question which is different from the previous question that I have given to you? Guys, tell me quickly, is there any question which looks like different from the previous question that I have given to you? Or all these are same? Yes or no? Same. Okay, that's cool. Have you got the right answer? Who has got the all 4 right answers? Okay, that's cool, Itanagar. Shillong, what's your status, guys? Okay, how many of you has got the right answer? In the counting, count first quickly the number of students in Shillong who has got the right answer at the 2 different center. Okay. What the other one? Okay. Okay, guys. So I hope so you have understand the mechanism. Okay, that's fine. I hope so you have understand the mechanism, guys. Who has got the wrong answer? Don't panic. Relax. Just think about the question. Okay, it's okay, dear. It's okay, Zainabadi. But you have to make sure that I hope so that there might be problem with this one, ND2, ND2. Remember, this is the deuterium, which is the isotope of hydrogen, and I have told you that the hydrogen comes from the solvent. So guys, remember, this will replace this deuterium, so you will get the NH2. Are you getting this, guys? Actually, question number first and question number 2 are quite easy to understand. That initially he has got the H, see, and in the answer you are also getting the H. But in the question number 3 and 4, there is deuterium, and which will be replaced by the hydrogen. Okay, and these are quite important questions. Ultimately, these kind of questions will be asked in your examinations that you have to encounter with. Okay. So guys, let's move on to next. I'll give you 2 more questions and you have to solve them. This is a wedge and dash representation of the bonds. Guys, attempt this question as well. Tell me the right answer. Attempt these 2 questions as well. Attempt these 2 questions as well. Done? Guys, have you done this? Okay, that's cool. Shillong, what's the status, guys? Raise your hand. Okay, that's cool. That's cool. See, let's see the answer. I'm writing in the question actually. So this is the answer. You will get ND2 over here and you will get NH2 over here. These are the answers. Tell me who has got the right answer. Both right answers. Okay, there are many students. Many. Kya? Are you getting a little bit comfortable with the organic chemistry? Raise your hand. Okay guys, this is the Hoffman bromide degradation reaction. Now, see, all the reaction mechanism would be same, that I'll discuss after that. Now, let us discuss the next one. Okay, that's good. Let us discuss the next one. Guys, I'll give you a hint for this reaction mechanism and I'll give you 5 minutes to write this reaction mechanism on its own. Sorry, you have to write it on. You have to write it by your own. I'll give you 5 minutes for this one. Okay. I'll give you a hint. First of all, this is a general reaction. This is reaction number 2, which is Lausanne's reaction. Lausanne reaction. See. pH, CO, NH, O, SO, CS3. We are using base with water and we are heating it. Okay, and the final product will form would be this one, primary amine. Okay. To write the mechanism, I'll give you a hint. This is the step number 1 that I'm doing for you. This. O, SO, CS3. See, that I'm writing in the green is the leaving group actually. Okay. And look at this reaction very carefully. This is in the presence of base. This is the actual reversible reaction. So, this is the leaving group. This is H. This is N. So, obviously, there will be generation of nitrogen will takes place. C double bond O, N, vacant orbital plus H2O plus O minus S double bond O CH3. Guys, rest of the steps will be same. We have got the nitrogen. There will be Wolff rearrangement in the next step, and after that there will be attack of OH again. There will be proton transfer. Means rest of the steps that we have discussed in the previous mechanism would be exactly same. So I'll give you I'll give you 3 minutes for this one. Write this mechanism. First of all, note it, copy it, this mechanism. This reaction, and then write the mechanism. I'll give you 3 minutes, and then you have to match when I'll write the answer for you.
that how many steps you have right, absolutely right. See, after the first step, rest of the steps will be same. Do it. Do this. Guys, reply me when you have noted the sound, as well when you have completed the mechanism. Everybody has to write the mechanism. Next steps. Those who have completed will reply on the chat screen. I'm waiting. With their name. Shillong, Itanagar, Senapati. The student who has written the mechanism will quickly reply on the chat screen with their name. Okay. Navam has done from Itanagar. What about Shillong? Priyanka from Shillong has done. Annie. Okay, Nisha has done. Balajit has done. Lima has done. Paul. Paul has done twice. Nitish has done. Cool. Okay, last 30 seconds. 30 seconds. Let's see how many names would be there. Last 30 seconds. Elisa. Good. Timing's running out, guys. "20 seconds left. I haven't got all the names. Twenty, 15, 10 seconds are left. Okay. Okay guys, time up. Okay. It's okay. I hope so in the next time I'll get name of all the students on the chat screen. Okay. Okay guys, so let's continue with it. I'll complete this mechanism for you. This is step number 2. See, pH. I think you have got confused with the pH. CO N. Vacant orbital. Remember, this pH can be written like this, and it will attach to this nitrogen, and these electron pair will shift over there, and after that it will look like this: pH N double bond C double bond. Okay. In the next step, there will be OH minus. OH minus will attack to this carbon. This electron pair will shift over there. You will get pH N negative charge C double bond O OH. After that, there will be proton transfer. Ultimately, we have discussed that this proton will shift over there. This proton. 1 second. This O and this H. Okay. So this proton will shift over there. H plus transfer. It will look like this. pH N H C O O minus. And look at this very carefully. This is actually CO2 that I have just told you. Now, guys, I am not separating the steps this time. Okay. For that, you can refer the previous mechanism. I am writing the answer. Okay. So here, pH N negative H and CO2 will be released. And again, there will be use of water, and you will get pH NH2. So guys, is it clear to everyone? Guys, is it clear to everyone? The Lawson's reaction and the Hoffman bromide degradation reaction. Is there any doubt regarding this one? Any doubt? Anybody? Okay, Itanagar is clear. What is the status of Shillong and Senapati? What's your status, guys? Remember, the upcoming 3 mechanisms would be same. Will be based on this concept. Okay. Okay, that's cool, guys. So that's all about today's lecture. Okay. So see you next time, guys. Take care. Bye bye. Have a good day.